All right, so you want to start an AI agency, but you're not sure what to sell. This video is going to go over the toolkits that AI engineers use to solve their clients' problems. I'm not going to tell you exactly what to sell because that depends on the industry, your background. It's a very specific situation by situation thing. So I'm just going to give you the general framework that I'm using and that most AI companies use to solve their problem. And by having the tools, you know, like if a client comes, if you're on a sales call or if you're cold calling or if you're cold emailing, and somebody says, "Oh, can you build out this thing for me?" You'll have all these tools laid out and you'll know what you need to do based on these tools to get the result that they're looking for. Let's get started. So high level, right? I want to go business 101 before we go into AI 101. Because ultimately we're all trying to make money here, right? We're not trying to be AI research PhD experts. We're just trying to make money using AI. First thing is, right, every business, and with this agency model that you're using, right, you're just solving problems. I'm gonna put P on the left side and the solution on the right side, right? So the business is paying you because you're solving their problem. It just so happens with AI specifically, you're automating something. So for example, I'm gonna use customer service, right? CS for short. When we build a chatbot, which is what everybody knows and I guess thinks about with the whole AI agency model, what's happening is before, let's say a business is getting 1,000 requests per day, right? They're doing amazing, but they just have a ton of requests, a ton of questions. And the business owner can only hire like five customer representatives. They're losing a ton of money on the people that they're not getting back to right away, right? Because they lose interest, whatever. So what a chatbot does is that it essentially replicates what a customer service person does, but in the form of a computer, right? And so what that means is we go from, let's say 3 to 4 days of getting back to customers, like assuming that somebody's manually going in and emailing people back, to 3 to 4 seconds, right? You see the value here, right? Notice how none of this has to do with the fact that the word AI is in here or the fact that the chatbot is using AI or an LM or whatever. It's just that from a business point of view, what's happening is they're losing money because they can't get back to customers, and so we slash that in like some amount, X amount, like from 1 day to 1 second, right? It's a pretty sizable difference here. I don't know what the actual number or multiple is. That is a problem we're solving using a chatbot. And that is the way you need to approach solving any kind of problem, really in any business. Now that we have the foundation, or now that we understand what exactly it is we're trying to solve, I'm going to give you some potential things that go in this box here. When I say potential, I mean all AI engineers use these tools, so I'm just going to give you like an exhaustive list here. But the goal of this video is if somebody comes to you and says, "Can you build this thing out for me?" You can pick between these tools and you'll be like, "Okay, yes, I think I can do this. I just need to like use this thing, and that thing." And together it should yield a result. First is LLM, right? You're like, okay, no kidding. I want you to understand, right? When we say LLM, ChatGPT is not the only thing out there, right? Let me actually break this down first. So there's closed source and there's open source, and you're just gonna have to bear with me on my handwriting. When we have closed source, there's OpenAI, but that's just one, right? And okay, let me define these for you first. Closed source is any model where you don't see the model weights, right? You don't see the internal code. Typically, you just use an API. API is what you use to kind of connect between different services on the internet. You just use an API to connect and use somebody else's model, right? Like in the case of OpenAI, we have no idea how GPT-4 works. We don't know how many parameters it has. We don't know what the training data is. We don't know the model weights or anything like that. We just know it works well. And it's cheap. So other examples though, because it depends on the use case, there's Claude, which has an insanely long context length. So in like situations where you have just a ton of input data and you want something that's like OpenAI, like I think OpenAI is GPT-4o, like with an O on it. Its context length is like 100K right now. Claude, I believe, is like 200, 300. I don't know. These numbers change every single day. A new model comes out. But you see what I'm saying here? And then there's also Perplexity, which is known for their insanely fast API time. If you want something that's real time, like voice, any kind of voice application where you need to respond to the prospect right away to make it seem like it's a human conversation. You see like the rationale I'm doing here for everyone. Like that's what you have to do as an AI engineer. Right? You need to figure out what tools within these tools can I use to give my client the best performance. You're kind of like a tester. You have this big rack of different things that you can pick from. You need to pick the right one. That is your job as an AI expert. So that's on the closed source side. On the open source side, this is less well known. I don't think anybody talks about this, but besides like the AI research community, but AI business doesn't really talk about this. There's Llama, there's Mistral, which recently also went closed source, and there's Falcon, which is an older one. And there's way more models. I'll put a link to the leaderboard down below. right? This changes, all of these things change. So the bigger point here is people typically use open source models when they want to keep their data private. Like any kind of medical field where you're dealing with HIPAA compliance, or in Europe, GDPR compliance, they don't like the fact that these closed source models, you're giving like somebody's personal identifying information, PIIs, to this third party company, right? Because what happens if like this OpenAI gets hacked? The data is gone, right? And like who's going to be to blame? Like it's just a mess. It's a legal trouble. Like, hey guys, real quick, if you're interested in using AI to help your business save time and make more money, my company Apply GPT helps you do just that. I'm going to put my links down below, and enjoy the video, guys. On the other hand, with something an open source model, the difference is you completely own this, right? Like you see the model parameters, you see the model, you see the code, and you're responsible for implementing this yourself. So if I want to deploy a llama, right? And they have some ready to deploy things now as well, but if I want to keep this super containerized and safe from any outside thing, I need to go in and deploy this model myself, and something like EC2 on AWS, right? Any kind of private server. I know I'm getting a little technical here. I have to back myself up. But the point here is, if you want to have complete ownership, like let's say it's a startup, another example, right? A startup that wants to get funding and eventually wants to sell. You're much better off building an open source model for them than closed source, because open source is something that you own, right? Like when the company sells, this is specific to them. And so like pros and cons, again, I'll make a separate video on it, but OpenAI, right? You don't have to worry about actual model deployment or anything like that, and it's also very cheap. But the con is you don't have any control. Like let's say one day GPT-4o just breaks. You're kind of screwed if your company is built on OpenAI. Like there's nothing you can do. On the other hand, with open source, because you have the code, you're responsible. So you take on more responsibility, but you also get more in return, right? And typically, like this is also changing, but I have to kind of preface all these things. Open source models are much stupider than closed source models. Like I think we're approximately a year behind. I think the best open source model right now, like Llama 3, I think it is as good as GPT 3.5 or GPT 4. So you need to make these pros and cons, but this is a tool, right? This is a tool. So now I zoomed in to the graph. I'm going to zoom back out here. LLMs are like a brain. Think of it like a really stupid human, right? Like IQ, let's say 20, IQ 40. I don't know what the official IQ is. Where LLMs come into play is anytime you want to manipulate some kind of text data. So like if somebody has a bunch of data and they want to summarize it, you already do this use case. The LLM is the one that's solving it. It's going to the solution box over here of how you can actually summarize and cut down that data or transform that data in any form. So that's the first thing. The second thing, I know I went super deep, but and this video is going a little longer than I wanted to, but I want you guys to understand. The second is vector database. So vector database, I'm just going to go deep. It's fine. Vector database, I have already made a video on RAG, but I'll give you guys a quick refresher here. You use a vector database, you should think vector database when somebody has more documents than that can fit in an LLM. So somebody has 1,000 documents and you can't put all of that, you can't just stuff that into the context length of an LLM, or with open source you almost always have to use a vector database. Then you need to start using this tool, because the problem that it's solving, right, with the same framework here, but internally, as a business, the problem it's solving is if I have a ton of documents and I can't figure out which one I need to use, the vector database is the one that decides which document I should pick to answer the person's question. Like, for example, the one that everybody kind of uses here, right? If I have dog and cat, and the reason I'm graphing this is because what's actually happening is these documents are getting graphed in space. In actual like Euclidean space, but it's in like dimension 3048 and something really high that we can't visualize. So it's 2D just for explanation. But let's say dog, cat is a document and lion is a document. What's happening is these things are getting plotted based on their similarity. So dog and cat are plotted close to each other because they are similar in meaning. Like when we in the English language, right? Because LLMs are trained on English, like on something, right? It's on actual data. So in the data it's trained on, which is based on what we say. We typically use dog and cat in a very similar context. Like, oh, what pet do you have? I have a dog, or I have a cat, or I have both. My dog and cat don't get along. You don't say, my dog and lion don't get along, right? Or I took my dog out for a walk next to the lion, or like the zoo or something like that. You don't really say that. So that's why these things are plotted farther apart. So the distance actually means something. That is like, this is a vector. That's why it's called a vector database, because you have a bunch of documents and they're plotted in vector space. And what's happening is, let's say I have a question about a pet, right? The way I figure out that I need to use these documents here is I also plot pet in that same space, in that same coordinate plane here. And I just look at and see which documents are the closest. So what might happen, you're probably wondering, is let's say this is sheep, right? And I'm saying I want to search about pets. What might happen is dog, cat, and sheep might be returned, right? It's not 100% guarantee that the right document is going to be returned. But it's still better than nothing, right? Or still better than going one by one and evaluating, does this document work? No. Does this one work? Does this one work? No. This is like, that's the functional purpose of a vector database, is to pick the right document if I have too many documents to pick from. So when I have a question about pets, I'm going to plot pet, and because remember with the English language, like the same thing applies. Pet is going to be plotted close to dog and cat because in the English language, or whatever language you're using, these are similar in terms of meaning, right? That's why it uses semantic understanding, the understanding based on the meaning here. So it's not a text-to-text match, right? I need to make that clear. It's not the P and the D are matching and like we're going like a traditional, like a Lucene-based database. This is like pure meaning-based stuff, which has its pros and cons. But for now, like this is the tool that we use as AI engineers to pick the right documents. So very simply, this horrible drawing, if I've got a ton of documents, and this could be in form of documentation, it could be SOPs, it could be old training videos that are converted into transcribed. It doesn't matter what. If it cannot fit the input context length, then you use a vector database to convert all of these with a question into one document. When I say convert, what I actually mean is you just pick, not actually convert. That's the wrong term here, but you get the idea. That's vector database. That's the second tool, and these two are the biggest ones. So these two together are the AI piece for generative AI specifically. Like if you're watching this video and you're interested in making money with AI, I'm going to assume it's just generative AI and not like clustering GLM or any kind of like the older techniques, right? You get the idea. So this is the AI piece here. But notice, like we're trying to provide businesses with value, right? We want like a real solution where they're going to make money off of us. That's why we're here. And so just building an AI solution is not enough. You need to actually use that AI solution in that business. And the way that's done is by using software engineering, right? SWE for short. Like to drive this point home, if you build something that transcribes your, let's say your meetings or something, like a good example is with Google Meet. Like you can put these bots in there, it listens to everything, and then it transcribes and spits everything out. If you just built that standalone locally on your computer, it doesn't mean anything. It's not providing any value. You need to integrate that into Google Meet. So the SWE part, that's the software engineering. You're like writing code to do the actual integration here. But in your case, like it could be with Google Meet, but the actual process of integrating the AI solution that you built, the Gen AI solution that you built, with the client's tech stack, whatever technology they have, it could be a WordPress website, it could be Webflow, or it could be like a traditional, like a Node.js, anything really, any platform like Bubble, it doesn't matter, like whatever platform. That is what software engineering is for. That is why, and you hear a lot of people online say that you can use no-code tools. You totally can. It's just that when you start working with companies that like that higher level that are like making, 500, 1 million, 2 million, they kind of expect you to write custom code. Like if you just tell them I'm gonna use a make.com automation, they're like, what are you talking about? Like I've got a tech team in-house. I want something that's not going to cost me a lot of money. No-code tools typically are going to be more expensive because they're no-code, they're selling no-code. The fact that you don't have to write code is their arbitrage opportunity. So you get my point here. If you can use no-code and the client doesn't care, then go for it. But in terms of over here in the SWE category, typically it's servers, some kind of website integration. So for example, right, like a good example is, I have this case study on my YouTube, but I had a relocation client. I built a relocation assistant for them. The relocation assistant was the AI piece, right? I built that thing for them, but they wanted me to integrate that with their SaaS platform. And so that's where like I built a server, I built like the actual website, front end and all that. I took care of all of that for them so they didn't have to worry, right? So websites, oftentimes you might have to go in the cloud. This is as you kind of start going up, right? This is not like your local small business kind of thing, but if all their code is on AWS and that's how like their infrastructure is managed, then it's probably easier for them just to put in like a new server on Amazon EC2, AWS EC2, than it is to kind of have like a separate server on Replit or anything like that. So I don't want to leave you guys empty-handed, so let me kind of give you some examples. So with servers, I think Replit is a great start. I'm going to put it in the description. And again, not affiliated in any way. I'm just putting the links down, copy pasting it. All right, with website, if somebody does want you to build like a full website, full-blown website platform, or even a SaaS, right? That's a pretty common thing. If you want to go down the route of helping somebody else build their startup for them, then a good combo is WeWeb and Xano. These are both no-code tools. That's why I like them. Because I mean, building a SaaS from scratch, that takes a lot of money, a lot of time, a lot of resources, and you need development experience, and it's just a mess. So these two things I've noticed have helped me kind of speed that process up by quite a bit. And cloud, I mean, I'm AWS native, but you can use whatever you want here. Typically, it is whatever the client wants. But if you're trying to go for ease of use, then I think Replit, like if they want to serve in the cloud, Replit's good. But I mean, with this, like sometimes like they want some kind of security measure, or they want to use it within another microservice. And this goes to a bigger point that like most of the AI companies that are making money, I'm not just talking about the ones that are on YouTube. I'm talking about like the companies, the real AI companies that have been around before this whole ChatGPT revolution, right? That have AI scientists and AI engineers. They all have custom solutions, because the reality is every business has a different problem. And if you need to solve that, you need to be a custom solutions agency. If you're solving the same problem again and again, it's going to turn into a SaaS. I have a separate complete rant on that in my channel. You can check that out. Another thing that not as many people talk about. But this video turned out to be 20 minutes. I hope this was useful. Like, I hope that rather than me kind of giving you generic stuff, I started going into nitty gritty, because that is what you're going to need if you want to start on your AI journey. And I'm going to make separate videos on each of these and like pros and cons and like which ones to use and all of that in a future video. I just can't get too deep because the video becomes extremely long then. With that being said, thank you guys so much for watching. If you enjoyed this, please like, comment any questions you guys have. I'll respond to everyone. And subscribe. Thank you guys. Bye-bye.